How do we evaluate logarithms without calculator? We are going to discuss a very simple strategy with wide variety of examples. Here are 10 questions for you to practice. We are going to take them one by one. I am Anil Kumar. Welcome to my playlist. We have organized list of videos for you to practice and master these strategies. Let us now begin with the solution of these questions. Question number 1 and 2. Evaluate logarithms log of 1000. So when we write log of 1000, in that case, the base is 10, right? Whenever it is not mentioned, then by default, base of this log is 10. We need to evaluate, so let us rewrite this as equal to x. So x is the value of this logarithm. First step is always to write it in exponential form, since we are very familiar with exponential form, correct? And keeping the same base, we can write this as 10 to the power of x is equal to 1000. Now 10 to the power of x is 1000. That means what? Well, we need to have the same base to solve this exponential equation. Since you are great at solving exponential equation, from now onwards, it should not be difficult, right? So this is 10q, right? Bases are same, exponent or the index will be same. So we get the answer x equals to 3. Makes sense? Clear? Right. Now let's do the next question, which is log to the base 2 of 64. Step number 1, write this as some variable x. Now write it in exponential form. Base is 2, so 2 to the power of x is equal to 64. We need to now write 64 as power of 2. So we have 2 to the power of x is equal to 2 to the power of 6. So that gives us x equal to 6. Simple as that. Makes sense, right? No problems. Now let's take up slightly difficult questions. We have log 0.1 and log to the base 2 of minus 4. Now when I write log 0.1, let us say it is equal to x. Base is 10, right? So we'll rewrite this as 0.1 is equals to 10 to the power of x. So it doesn't matter whether we write 10 to the power of x on the right hand side or the left hand side. It is one and the same thing. As per your convenience, you can write. Important thing is that this base, which was 10, right, remains there as a base. Now, what is 0.1? Remember, 0.1 is actually 1 over 10, right? And 1 over 10 means 10 to the power of minus 1. And see, now we know minus 1 is x. So x is equal to minus 1, or we have evaluated the value of this logarithm as minus 1. Makes sense? So that's another way of doing it. Just making the exponential function with the variable on the right hand side. Next question is interesting. We have log to the base 2 of minus 4. If I write this equal to x, what do I get? I get minus 4 is 2 to the power of x. Now, is that possible? Well, 2 to the power of x, is a graph which is always increasing and is greater than 0, right? So, for this, we have no solution. Perfect. So, this reminds you that the y value for an exponential function is always greater than 0. We cannot have a negative value. Perfect. Next two examples. So, the difficulty level is slightly higher now. The question here is log to the base 16 is equal to 0.25. Let it be equal to x. Now 0.25 and 16, how are they related? Well, 0.25 is 1 over 4, correct? So we could rewrite this as log to the base 16 or 1 over 4. Makes sense, right? 1 over 4. So 1 divided by 4, quarter is 0.25. Perfect. Now we'll adopt the same method. So we have 1 over 4 equals to 16 to the power of x. Now how can I write 4 as a power of 16? Now there are different strategies to work with. What we can do is that we can write both as powers of 2, right? That could be better. You could write 16 as a square root of, 4 as square root of 16. You could do that. That could be another way of doing it, right? But I prefer here to use common base as 2. So let's rewrite both of them as powers of 2. So we get this 1 over 4 as 2 to the power of minus 2. You get the idea? And 16 is 2 to the power of 4, and then we have power of x. You see that? So now we have 2 to the power of minus 2 equals to 2 to the power of 4x. Perfect. Now you see we have the same base. That means 4x is minus 2, right? That means 4x is minus 2. Or x is equal to minus 2 divided by 4. X is equals to minus half. So we could get this answer as equal to minus half. Makes sense? So you see how we kind of did it. We wrote both as powers of 2 and then got our solution. Correct? Okay. We are going to use this strategy now onwards and we'll solve the next question, which is log to the base 9 of 1 over 3. I would like you to actually pause the video and do it yourself. So we have here 1 over 3 equals to 9 to the power of x. 9 is 3 square, right? To the power of x, correct? So on the left side, we have got 3 to the power of minus 1. On the right side, we got 3 to the power of 2x. And that means minus 1 is 2x, correct? So what is x equals to? X is minus half. Is that clear? See, we have solved this particular question using the same strategy. So x is minus half. Perfect. Let's move forward and take the next two questions. So we have now square root as the base. The question here is log square root 2 of 8. Let it be equal to x. That means 8 is square root 2 to the power of x, correct? 8 is 2 cube and square root 2 is 2 to the power of half to the power of x. That means 2 cube is equals to 2 to the power of x by 2, right? Now, you can solve this. Exponents are same. That means x by 2 equals to 3, x equals to 3 times 2, or x equals to 6. So we get this value as 6. Correct? Perfect. Now let's do the next question. Follow the same strategy, right? I could show you some other tricks also to work with, but I want to follow a same method consistently. Now, next example, we have log to the base 1 over 3 of 3 square root 3. Let it be equal to x. Means 3 times square root 3 equals to 3 to 1 over 3 to the power of x, right? Now 3 times square root 3 is 1 plus half 3 by 2, right? So this is 3 by 2. And this is 3 to the power of minus x, correct? And therefore, we have 3 by 2 equals to minus x, or minus 3 by 2 is equal to x. Makes sense. So this is equal to minus 3 by 2. Clear? So we are done this particular question where we have radicals. Now that leads to the last two. Log of 16, 30, 32, right? So we have this question, log to the base 16 is 32. Let it be equal to x. So 32 equals to 16 to the power of x. Now writing both as powers of 2, we get 2 to the power of 5 equals to 2 to the power of 4x, right? Because 16 is 2 to the power of 4 times x. So I merge the two steps. You see that? And we get 5 equals to 4x, or 5 over 4 equals to x. Do you see that? So we get our answer. Now see, we also teach a shortcut method. How do we get this answer? We can rewrite the given expression as log 2 to the power of 4, right? That is 16. And we are finding 2 to the power of 5. Do you see that? And if you see the answer, it is 5 over 4. You got the answer. So this is the shortcut method. So shortcut method is that if I have log to the base a of m for a of n, then the answer is n over m. So now, once you understand this strategy, you can actually adopt this particular formula to immediately write down the answer. Get the idea? So the last question I'm going to solve like this, right? So look at it carefully. So I'll write it slightly bigger. We have log to the base cube root of 3, right? 9 to the power of 1 over 7 or 7, correct? Now, both can be written as powers of 3, right? So we could rewrite this as log, this is 3 to the power of, because cube root, right? 1 over 3, correct? And 9 is 3 square. So I could write this 3 square means 3 to the power of 2 by 7, correct? So that is 9 to the power of 1 by 7, right? You could write like this. Log to the power of 3 to the power of 1 over 3, or 9 is 3 square, right, to the power of 1 over 7. So 2 over 7. Now, using this rule, we can write down the answer. Numerator power is 2 over 7, right, over 1 over 3. Do you see that? And therefore, the answer will be 2 over 7, 2 over 7 times 3 over 1, or 6 over 7. Perfect. So we kind of flipped it. So you can use this formula also to find the solution. In this case, it is going to be 6 over 7. Now, at this stage, we have learned a couple of methods. The method which was being used, say equal to x, is actually a very good way of doing it. You don't have to remember any formula with this particular method, right? So I like you to solve question number 2 with our previous strategy, which is write log cube root of 3 of 9 seventh power equals to x. Write this equation in exponential form, then solve it and check with the solution. Hope it makes sense. Perfect. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.